Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter written in Swift, and we've done mostly the language I expected to get done. So as far as kind of features of the language, I'd say we're all set for now. There may be some holes we want to fill in, but this will get us going. Today and tomorrow, since it's already Thursday, let's just finish the week with this. It's just potpourri. I don't know exactly what I want to do. I do want to first just start with a walkthrough. So we have this sort of overall design. You feed in a program text. There's some lexical analysis, also called scanning or lexing, and it produces a stream of tokens. Those tokens feed into syntax analysis. So lexical analysis is typically modeled with regular expressions. Syntax analysis adds nesting. So you can check for nested parentheses and things like that. And it builds up a tree of nodes. All right. And then in our case, we're doing an interpreter. So we take that tree of nodes and just kind of work our way through node by node. And when it's time for input, we get input. And when it's time for output, we produce output. If we were doing a compiler instead, we'd take that tree of nodes and generate code that would have the same effect. Okay, so what we'll do is we'll take a look at the stream of tokens and the stream of nodes, and then we'll jump into the actual code. Then, at this point, I think of, well, it's either quality of life kind of thing. So some of them are external, visible to users. One is that our syntax reporting right now is pretty minimal. And it reports the errors, but it doesn't really show where they are. It would be easy to get the reporting shown in the second, third, and fourth lines there. So 10 dim a 2 3. That's the sort of normalized view of the code. It takes out all the spaces except in quotes, and that's kind of what we work with. So right now our error messages reflect that. We could at least print that out, print a pointer to where we expected something or where we detected something, and a message there. That would be an improvement. The second one I'm thinking of is our REPL. When you print, it doesn't automatically scroll to the bottom, so you see what's printing out as it comes. It's more, it just prints, and then you have to manually scroll. We tried this once before. I'm willing to give it another half hour or so. We'll see. Another one is more internal things. Right now, the parser knows the token. We could push that back over to the lexer, make it own kind of the process of getting the next token and so on. The reason I might want to do this is because the parser is pretty big, and there's a pretty clear delineation of statements versus expressions. We could have two parsers that did those separately. I don't know. We'll see. The other one, the token type, make token type be cases only. So the way tokens are now, some of them have attached data. If it's an identifier, it says, oh, I've got the name right here. We probably could move that additional information up to the token and see how that goes. I don't know. I think that one's worth an experiment. It would change a bunch of code, so we'll have to do a little stepwise on that. And then lastly, I think there's missing objects, and we could simplify the parser and the interpreter if we had a little bit more support. One, maybe the symbol table or store, which maps names to values. And the other, the character stream and how we manage that, we could probably simplify the lexer. So I don't know. We're going to start with a walkthrough. I think we'll spend half an hour-ish on the REPL, and then maybe the token type thing, see how that goes. Okay. Oh, my clock's nice and slow today. Okay. Well, let me save this one here. Okay. All right, walkthrough. So we'll find the tokens first. So we're going to look at the interface things first. So type's the lowest level. We have this notion that you can be missing number, a string, a function, or optional, because there are some function calls that allow optional arguments. We haven't done, we don't have an array type per se, and that's a little odd. Okay, but at least for now, everything's either interstring. Basically, arrays, we just leave them as interstring, the type of their contents. We don't have arrays of arrays or arrays of structs or anything like that. So the nesting structure is not really there to require more. All right, and then token has two parts. So the top part is a token knows its token type, and it knows its location, its line and column. Okay, so which column of text it was. So when I talk about the error messages, we track that at the token level so we could report it at the token level. And token type, well, it's pretty, there's a bunch of them, okay? But we got this batch up top. The error message has a string, the integer has an int, the number has a float, the variable has a string. The one change I'm talking about is probably to migrate these types up here. So give this thing a string, give it a float, maybe give it an int. The way we use int might not make any, we could probably get by with the float. But if it had those fields up in the top token, we have a lot of places where you switch on the cases, and then you've got to carefully peel out the right argument from the thing. It makes a little bit extra work. The cost of putting it up here is you're losing some type safety, because now we would say every token would know about a string and a float, okay? And you'd have to know that, integer or number, it makes sense to look at the float, and variable, look at the string, and plus, don't look at anything. Plus is its own thing. So there's a little less safety if you do that, but I think it may simplify a bunch of stuff, and we'll take a go at it. It'll be one where we make sure we're starting from a clean slate, and if we don't like it, we'll put it back. Okay, but anyway, when the tokens, the lexer takes the character stream and it produces the sequence of tokens, and basically many of them can just be matched up as a character, plus and minus and so on. Some of them have a little work, the integer or number, variable, string, those all have to kind of accumulate some contents, okay, according to rules. And then there's a little bit of less than or equal, not equal. You kind of have to make sure those get checked in order. And then finally, down at the bottom, predefined, string and type. Okay, we'll need type up there too. There are predefined functions like mid-dollar, which takes a string and a couple of floating point numbers or integers and produces a string. Okay, so it grabs a section of the string out of the middle. All right, the next interface is the parse. And it's, well, we're going to work on from the bottom up on this one. The parse represents the tree structure we talked about. So a parse is a structure, and it's basically a structure with a list of statements. Okay. Well, maybe we can, I don't know. It's kind of weird to go from the bottom up, but that's what we're doing. All right. So one thing that statements may involve is expressions, and those missing, I think that's sort of error condition number. Oh, maybe that's the corresponding to an optional argument or something. Number, string, variable, predefined, user-defined functions, array access, and operators, unary and binary. And I think the reason it's indirect is that expressions also form a tree. So, well, mostly you notice it with this, right? So if you say 3 plus 2, it's a op2 of a plus with the left-hand side number 3 and the right-hand side number 2, or it could be another expression, 4 times 5, op2, so on. All right. Now, dimension info, for arrays, we need to know how big the array is going to be. And so we've got it as expression. You could probably require it to be a number or something like that, but we didn't. But arrays, we need to know, what's the name of the array, how many elements and how many dimensions, and what type. All right. Another one that's kind of a helper is printable. When you print, you can either separate the values by nothing, or you can put a semicolon, which I'm calling thin space, or a comma, which is like a tab, or it's just an expression of some sort. So the thing you build up to print could be any of these. All right. And then finally we get to statement, and this corresponds to just the normal basic statements. There's assign, which is let, x equals 3 plus 2. There's data statements. We just did those this week. There's user-defined functions, dimensioning arrays, end statement, a for, down here's a next, go sub, down here's return, go to if go to, the on statements we just did yesterday, print, read we just did this week, restore we did this week. Skip is do nothing. So statements like remark, they just turn to a skip, and stop, which is kind of a breakpoint. Excuse me. All right, and then they have some helpers, but that again is a tree structure because statements can contain statements. An if statement can contain the statements, to execute if it's true. And it contains expressions, which are their own recursive thing. Expressions can't contain statements, though, so you get at least some break. All right. That gives you the sort of interfaces, that tree structure from the parser to the interpreter. Okay. Let's start back at the lexer and just take a little walk. All right. The core of the lexer is matching things. So basically, we just run through this list in order. It's kind of I don't want to say this. I used to work at Digital or DAC years ago as a compiler person, and we wouldn't do anything this simplistic, I guess I would say, because it's a little inefficient. We're running through the list of possible tokens and finding one that might match, might be the leading, the next characters in this string. Okay. But we go through these in order. That way we know less than or equal. We look for the less than and the equal before we look for just a less than. Okay. Our operator tokens are here, the punctuations, all the reserved words. Notice each one of those kind of maps to its own thing. And then the predefined functions. So these are the ones that are in the library before you get going. Okay. So all that stuff is kind of predefined as, these are simple matches. Then we have a few leftovers. Let me jump down there. Here we go. So the core of those, so find prefix token basically runs through that list we just saw and sees if anybody comes up with a possible token. Okay. If it does, like maybe you saw a data for a data statement, it returns it. Okay. If it doesn't, then you get to the more complicated tokens. So numbers, they start with 0 through 9. Strings start with quote. Variables start with letters, and then otherwise unexpected. Okay. So let's just go in number. It's probably the most complicated of these. And basically, let's go down to our grammar. Oh, I don't know if we defined, we said legal and not legal. Numbers, they have a string of digits. They optionally have a decimal point followed by more digits. They optionally have an E. And if you have the E, you have to have possibly a minus sign, but definitely more digits. Okay. And our our lexer basically reflects those rules. Repeat any looks for a string of digits. We check for a possibility of a decimal point. If there is one, we require more digits. And we're accumulating the value in string form. Okay. We look for that E, and we make sure it's not E followed by some other letter. Okay, because it's only if it's followed by numbers that we're going to be looking for it. And then we should see a string of digits, and we attach them to the thing. And then at the end, we decide, is this thing a float or an int, and return one of those two token types. We went back and forth on this. It may not be strictly necessary to have the int, but it's handy sometimes. If you say go to, you can't say go to 37.5. You can go to 37 or you can go to 38, but we don't allow decimals, decimal point line numbers. Okay, so line numbers are the big case that ints are handy. The other one is array dimensions. It's not that you have to, but it makes sense. All right, and then then the other type, string, we look for quotes, and if we find it, we don't, and if we don't find it, we error out. And that was our prefix token. Variable, we're looking for in this basic, it's a letter followed optionally by a digit, followed optionally by a $sign. $sign means it's a string variable. Okay, and then let me just touch one more thing, was normalize. I don't know, this is the greatest thing ever, but basically we're going to try and we want to make it uppercase and remove any spaces, except we don't want to mess up our quoted strings. So we basically split the input line looking for subsequences, and we split them according, looking for double quotes. So all the line is split according to whether things are in or out of quotes. And we know it has to start with a non-quote. So we just, every other one is either part of a string or part of the normal code. Excuse me. So if its mod is 0, like the first one is, we take the string, we replace space with nothing, and we uppercase it. So that's the normalizing part. If it's a piece 1, well, we put the quotes back around it and make a string out of it. Okay, and then we join them all together. So we're doing a very minimalistic kind of parse, just to form. Well, it's kind of like here, this tend-ma. Okay, it finds, well, there's no quotes in this line, so everything's in the first piece. It squeezes out the spaces and uppercases it. Okay, and otherwise everything here is kind of like character management, a little bit of stuff to repeat, kind of a helper if you want to find characters in a range, like A to Z or 0 to 9. Okay, and that's pretty much it. So when somebody calls next, okay, we figure out the type of token, okay, and wrap up basically the current line number and the column and return it. Okay, so this is the interface. This is really the true public interface. I probably should even mark it public, but that's okay. I guess the one thing I left out was description of unquoted string. We had data statements this week, so if you followed along, you already know about it. But data statements, you can have strings that aren't in quote marks. They're still separated by commas, and they still get uppercased and all that, so it's no problem. All right, so that's the tokenizer, the lexer. Then the parser, it's driven by the grammar. So let's see what stuff it knows. So max line number, fine. It knows a lexer. It keeps track of a token. it keeps track of a token type. I don't think I don't think um, well, if we get rid of we we probably should reference this as token, and this should be the thing that's in the token itself. But we didn't have a token when we started. This was the token. We changed the name to token type and added the line number and column number stuff. Okay. Um, all right. So here's our interface from the parser perspective. I'm going to get the next token and set the token type into token. Okay, so I always have the token type and the token around. Okay, again, let me go down here. Basically, it's a grammar driven process. So let's see, a grammar. Okay, programs consist of lines. Lines have a line number and a statement. Um, statement. Oh, we left out. Well, this isn't exactly how we're doing it, but statement goes to, how do I do this? It's not going to quite correspond, but we also allow you to put colon and more statements. Okay, you can have multiple statements on a line in this basic. Okay, and so you're either going to find a rem, a print, a goto, an if, and so the way this is coded, it's called recursive descent. It basically says every time you have a grammar rule, make a method, and when you want to match things, you call something that says match this. Well, let's do if. You say match the if, okay, and skip over it. Now match the expression. So you're calling the method that corresponds to expression. Find this token exactly, okay, and then find this token exactly. So sequential code corresponds to walking through a series of, concatenated syntax, I guess. You can have optional values. We use this notation where those are in brackets, square brackets. And so I'm saying you can say input variable, and then you could have parentheses and expressions inside, more parentheses, but that's optional. So in this case, we're saying your input variable can be an array access, okay? And we can also see the repetition. The curly braces, they mean 0 or more, okay? So square braces is 0 or 1, curly is 0 or more. So I can say expression, comma, expression, comma, expression, comma, expression, and so on, okay? And then you're allowed to have multiple variables if it's a comma separated list of them, okay? And so this gives you repetition and alternatives, and same thing here for alternatives. My statement is going to look and say, are you a rem? Are you whatever starts print statement, which we know is print? Are you a goto? Are you an if? Okay. And we expect to see that kind of structure somewhere. All right. So parse, here's single line. Okay. Try line. Okay. And then there's error handling. Okay. We'll kind of skim the error handling, but a line says it better start with an integer token. All right. If it doesn't, then we hit the error down here. All right. So if it starts with an integer, we skip past it, and we make sure we apply some semantic rules that say, hey, you got to have the right range, and then we call statements, okay? And statements is a method corresponding to a grammar rule that's going to find the rest of the statements. And then at the end, we say, hey, you really should be at end of line by now. If you're not, there's extra stuff there. And we return a parse. So that's the tree that we built up. All right, now here's statements. Statement says try one statement. And if you don't see a colon, then that's the only statement on the line. Just return it. Otherwise, accumulate the list of statements. And so we return those. All right, now let's go to statement. Okay, well, here you can see this is like statement goes to def or dim or for or data. My alphabet skills apparently are atrophying. Data before def. Data def 4 comes after end. Oops. I guess I'm morally obligated to check the rest of them. If input let next on. Okay, well, I did good up till here. Okay. But anyway, we can see each of these has, each of those cases goes to yet another method. All right. And let's, trying to think of one that's a little, well, let's do 4. Okay. So do 4. Basically we come in, we're looking at the 4 token, so we'll skip past it. And then the syntax is for x equals 1 to 10, step 3, where step is optional. So we're going to say you must have a variable. We make sure you have an equals, and if you do, we skip past it. And then for x equals 1 expression, we require this to be a float as opposed to a string, so another semantic rule. Then we have the 2 is required, and then an expression, and again we require that to be float. And the step by default is 1. If we have a step, then we skip past the word step and we figure out what the step is, and in the end we put out this parse. It's the for statement with the variable, the initial, the final, and the step. So basically everything you need to do to handle that. Okay, here's the next corresponding. You say next x. Well, we skip past the next. We require a variable, and we return a next structure. Okay, and every statement has a method kind of like that. Okay, user defined function call. You say def fn parenthesis name equals expression, something like that. Okay. Yeah, def variable we save the parameter, and down the bottom fn plus parameter. So you define these as fna, fnb, and so on like that. It's just a little weird piece of basic. All right, but it requires parentheses. It type checks everything and so on. Okay. I don't think it's useful to run through every possible one of these. I guess these type checks, these are kind of semantic things. You tell me a bunch of types and a list of arguments. I'm going to make sure, this is for function calls, I'm going to make sure that your parameters match up and each type corresponds. So if the function takes a string, an int, and an int, we're going to make sure that parameter types match to arguments, that each one of those is compatible. Okay, and compatible is, if they're the same, that's great. If one of them is optional, we allow it, and otherwise you've got an error. Okay, so we have the parsing and a little bit of semantics. There's not a ton in basic, but there's some enforcement of types and so on. All right, and then finally, let's go over to the interpreter. Okay, so the interpreter, it's got to maintain everything, information about everything. Okay, so let's see. We need a program, the input. We need an interactor, which handles I/O. And then we need a parser. We're always going to maintain a current parse. And we're going to track the locations. So in the original BASIC, like 1964 vintage, you could go to a line number, you could be on a line number. There was nothing beyond that. In our basic, we allow the colon for multiple statements per line, and you can have situations where you need to jump into the middle of a line because of that. The if and the go sub cause it. So I could have statement go sub 3000 colon statement. Well, when it comes back from the go sub, it should return to the middle of that line. So our location has to account for that. Then we have some flags that tell us kind of the running state. So done means the program finished. Stopped is really the break point, and then awaiting input if it needs the user to type something. All right, and then we have the notion of data, which we worked on this week. There are data statements that provide kind of predefined values, and we have a structure that holds all the data statements. They're not really, I mean, they're interspersed with the code, but they have no function at runtime. You don't wait to execute a data statement until you see it in the code. You execute them all at once, in effect. Okay, and we keep track of which one we're working on. Then we have a couple of key structures. One is the store, and I think I'll move this up here. Okay, the store maps names to values, and this is really our variables. So basic, it's a very flat language in that sense. It's not like C or Java or Swift or anything else where you got nested scopes and all that stuff. There's kind of one level nesting in our scopes. You can have, we had those FNA, FNB, they can have their own variable, but otherwise we just go to the globals. Okay. And so the interpreter has to represent that. Now a compiler would probably turn these into declarations, number, var A of float, var B of float, and so on. Okay. Another piece of information we have to store is around our for loops. The way they are, they basically can nest, and you need to kind of track that nesting. So nesting almost always says, oh, I got to have a stack somewhere. And so we keep track of the name of the counter, the limit, and the step, and where is the I guess that's probably the location. I'm not sure if I think that's probably the location where you should return to run, the top of the loop. Okay. The interior of the loop. And so when you get to the next statement, you can pop this off and say, oh, I'm going to increment this variable by this value, check it against this one. And if it's still in range, jump to the location. Okay. And then finally for go subs, they also have to have return stacks. So the original basic, you couldn't even call a subroutine within a subroutine. It was one level deep. We're following the later basics, and we'll let you have a stack of them. Okay. And so when you return, we need to know where to go to. I don't know. So I hope that background noise isn't coming through. All right. Now, there's some setup of all that stuff, but the real heart of starting things is run. Okay. And this we took care of yesterday, kind of resetting everything back to the original if you try and run twice. Sorry, let me see if I can cut down that noise. No. Okay. You do some setup, and then the heart of the interpreter is this run loop. And it's very common for interpreters to have loops like this. They're sort of the central place that does it. So it looks up the current line, and it parses it. Okay, so we always start with that. Then we step, and step takes care of one statement. All right. And at this point, we check, should we run? That was just up here somewhere. Well, it's basically checking those flags. If the flags say it's okay, we're going to go do the next statement. So we find the next location. If it was a go-to, it might be different. Otherwise, it's within the same statement, or maybe it fell to the next line. If it's a failed go to, we check for that. And then otherwise, we parse the line and figure out the location and then do a step. What does step return? Well, step doesn't return anything, so I think that's... It probably did at one point. I'm pretty sure we were returning strings at one point, but we don't now. Since we assigned it to an empty, an underbar, it didn't care. Okay, now step is really the heart of the interpreter. We're in our tree, in effect, our parse tree, and every one of these statement types, the interpreter has to know how to do one statement. Okay, so this is every time we edit a statement, we edit a case to this. And let's let's take this one, this if go to. Okay, so mostly I have a method corresponding to each. So if go to is like if expression then line number. Okay, and you can see that's reflected. We pulled these out of the tree structure, and we're saying, okay, you got to tell me what to do if expression and location. So we evaluate the expression in the globals context. That's our store of, our map of variables to values. So evaluate is focused on evaluating expressions. And then we make a decision. If the condition is not a 0, then we should go to it. Okay, so we're going to change next location. And we return back up to our function. Let's see, can I get there? Yeah. We return back up here, exit the step method, and we're back in our main run loop. Okay, so yeah, we tried step and we did what it required. And now our location is a new place in our tree, and we find that and do that. Okay, and so every bit of what's going on in this is really oriented towards doing that sort of thing, basically applying the semantics of the language a node at a time and doing whatever it requires. Okay, the next one is evaluate expression. And, the first one was doing statements. Now we're doing expressions. And you recall, here's our expression structure: numbers, variables, strings, and so on. And each one of those, you do something. Okay, so op2, here's if you have 1 plus 2, your token is a plus, your left is number 1, your right is number 2. We'll evaluate the left, we'll evaluate the right, and then we'll apply the token. We'll look up the token that's a function, operators 2, and we'll apply the function to the operators and return that value. So let's just go see this thing. Okay, here's plus. It says, hey, treat the first number as a float, treat the second number as a float, add them together, and put the result in a number. Okay, our value type. Every operator's got its own definition. Okay, some of them are a little more complicated. The booleans, the semantics require some playing around with convert to integer and stuff like that. But okay, we can do it. And that's really what it is. So adding a new operator is not too hard. I don't know what you'd add, but it's just a matter of adding to the expressions and then figuring out the definition of this thing and how do you do it. Okay, and so I think well, I'm not going to go through piece by piece, but it's all pretty straightforward. I guess let's find one that can make an error happen. Yeah, okay, here's do return. All right, so some cases we're going to have error situations that could occur. The interpreter has to check for those. And so in this case, a return statement, well, your return stack better not be empty, because that would mean you just called a return without ever doing a go sub. Okay, so we don't have anywhere to return to. That's an error. Return called before go sub. Otherwise, we do the semantics. We pop the return stat value and transfer to it as a go-to. Okay, so this is very low level-ish, right? It's almost CPU level kind of stuff. What does it mean to do a return? Okay, well, basically it involves a go-to. All right. So adding a new statement is not too hard. They're all kind of independent and kind of one method per statement kind of thing. It may need some helpers, but that's okay. All right. So I would say we did a good walkthrough there. We've seen the critical pieces. I did make some tweaks, spacing and reordering, so I'm going to run all my tests and check this in. I don't see anything. The worst thing about it is these methods, these classes end up long. Okay, almost 700 lines to the interpreter. I kind of regret that. Minor text changes. Okay. And it really is, it reflects every piece of the language somewhere. So, it's, I don't know. You could probably make a case, like, instead of doing this with methods, one per thing, you could probably have little class instances or something like that. It might be an improvement. I don't know. I don't think it's too bad as it is, but you probably could do something like that. I think for us, I'm okay with where we are. I wouldn't have objected to doing it the other way, but it would probably be an improvement, frankly. In principle, another way to go, you could even attach the interpretation to these nodes and, make each one have its own definition there. That again, that may be a direction to go. All right, and then the parser is the other one that's good sized. Almost 750 lines, give or take. There's room for changing there, and we've used this recursive descent. And one of the things about it is, let me go to the grammar. When you're doing operators, let's get down there. Every level of precedence requires its own level of grammar rules. So expressions can be separated by ors. Each one of those could be anded together, could be negated, could be relational, could be plus and minus and factor and so on. Like you can see the levels, like, times is more closely binding than plus. Power is more closely binding than times, and so on. It generates a lot of grammar rules. I mean, we've got 10 or 11 grammar rules there, and this one's pretty complicated at the bottom. The sort of leaf of the trees. That gets a little old, and the parser, it ends up with all these methods. Let's see if I can find. Yeah, okay. Power. Well, let's do term. Okay, terms is the products one. So it's looping across the times and divides and builds these things up. But just looking at the shape of this, do something, check some tokens, do some more. Okay. And then compare that to the one for plus and minus. Do something, check some tokens, do it again, and then there's still some semantics and building up. But it's basically the same code. And I don't know, because you're calling, we might be able to unify it a little, make a generic thing, but we'd pass this as a closure. we'd have to pass this list of tokens. We'd have to know what to do to form them. It could be done. But you'd still have to have sub expression its own. You'd have to have methods for each one. They could just call a generic routine to do the work. That would be an improvement. We may do that. But I would look at a totally different parser. There's, in particular, I don't know. I started doing some work on parser combinators last year, maybe. I don't think it was earlier this year. And I didn't end up happy with where I got, but I ran across another article that's kind of inspiring me to try again. So I'm thinking, maybe I'm not sure what my project is next, but I'm thinking maybe do a bit of work on parser combinators. The other one I'm thinking of is switching to a compiler instead of interpreter, and I've got a refactoring that's supposed to make that happen. That one's very independent of the parser. It all focuses on the parse. So they're two separate projects, independent projects. But I would love to get this down to a much more readable kind of thing. And these parser combinators, they're basically let me draw the comparison. Recursive descent, we're structured in a way, the language is structured so that we can kind of predict everything that goes on looking at one token, almost always. And, we look for the minus. If it's there, we skip it. Then we try power. Well, it's going to look for its things. And then we try factor. And then we try exponents and so on. The parser combinator, it's recursive in the sense that it's going through this recursive grammar. It has to accommodate recursion, but it's not predictive in the same way where it can drive off. Is this the right thing? And I always know the next one token will tell me where to go. It's willing to backtrack, and I don't know. It's like, I know the language doesn't require it, but I'm hoping for enough expressiveness that it doesn't matter, even though, the original basics would never have probably never have done something so slow. But we'll give it a try at some point in the next few weeks anyway. And I'm curious how this ends up looking when that's done, because I think what'll happen is this grammar rule that corresponds to it is going to produce a tree. We'll probably put the semantics on top of the tree. So it'll probably be parse it, build a tree out of it, check it for semantics. And that's a bit of a shift. There is the notion of multipass compilers, and we could have said, oh, there's a lexing phase, there's a parsing phase, there's a semantic checking, type checking phase, and then we do the interpreter. But we did it in line, so could have been done that way. All right. Test passed. I think I checked it in. Blab, I guess. Okay. And so to do, well, I guess today we did a walkthrough. Okay, so 40 sessions of 2 hours each, right? So kind of 2.5 weeks of work to get what we got. Some stumbling around, but not completely. All right, walkthrough of code. Okay, next. Let's see, that was the walkthrough. Okay. I guess this scroll to bottom thing, it's annoying me. I did some research. Where did I find that? Okay. Well, he's saying it can happen in iOS 14. I think I might be using that on up here. Okay, well, this is another way. His approach before this was, it's like, well, if you wrote rotate the thing 180 and then you scale it by this and then you scale all the interviews and it's like, okay, that's really painful. But this is not exactly what we're doing in ours, so we'll give this a try and see if we can make that happen. I guess I could show it and then come back. All right, so let's see. We got our amazing maze. All right, so we'll paste this code in. And then we'll run it. Okay, it's waiting for input. Is something wrong? Okay. Notice the scroll bar here. I got to go down like that to get to it. I would rather it just kept up with things. Okay. Okay, so we want to fix that. Let's see if I... Okay. The other thing is, I don't know if I can change this. Clearly, I'm cutting off on the right, so my size is not really ideal. Let's do something about that too. But anyway, no auto scroll is really annoying me. Okay. It's probably a good time for a break before we get into that. So we'll take a break, 3 minutes or so, and come back and take another stab at a different way to do this auto scrolling and see if we can make it work. All right. 3 minutes. All right, welcome back. Okay, let's see. I'm going to close tabs to the right. Let's find our user interface. Okay, so our last try. Let me just check this in. I want to be able to revert this if I don't like it. Okay, so we tried doing on change and detecting it that way. So this one, whoops. Let's let's just duplicate the method for a moment. Oops. Okay. Well, I've done the wrong one, I think. How about the run view? Okay, so let's see if we can see this. Scroll view. So they don't have a scroll view reader. Excuse me, sorry. And this. And so they don't need an on change. Scroll view. Oh. Oh, they did. Okay. Scroll view. Vertical's the default. Scroll view reader. Lazy V stack. Let's just put a normal V stack. Scroll to end. Oh. We just have this. ID. Bottom. I have no idea what this is. Let's see if that's optional. Bottom, we defined. Oh. We defined it here. Let's make one. Let's make a bottom run. Using that name twice may have been a problem. Okay. So scroll view containing a scroll view reader containing a stack of stuff. Oh. See there, they scroll to that. I want to force scrolling to this. And I'm going to make it visible for now. That's kind of interesting. Right now, our interactor.output is just a single big string. It would probably be better if it were separate lines. All right, let's run this thing. I think we'll take our basic code again. here too, I'd like it to scroll to the bottom, but let's see if we can get this one. Okay, there's our marker. We're not seeing our message. And it did not scroll. I don't know if I want to try. If I try and make it a big array. I mean, that to me is the big difference with what this is. He's got notes is, I assume it's an array. Oops, whatever that is. Well, it's some sort of array-like object because you can scroll to the last item in it. I wonder if he has no notes, what happens there, but that's another problem. So on up here, I don't know, let's see what else we have for these. Okay, let's, what our choices are. Perform before this view appears. See, I would have thought our on change was the right deal. I wonder if I could say interactor.output. Observed object interactor wrapper has no dynamic member output. Oh, I'm spelling it wrong. That's probably a problem. Okay, let's find this. Oh. Okay. Oops. Yeah. Oh, golly. All right. Let's find. Runtime original. Okay, so then we don't need this. I noticed I have the reader on the outside and they had it on the inside. I don't know if that's significant, but this is the one that works now. Okay, so this is run view. I'm not going to print that. ID bottom run. Code view. This doesn't even make sense. Let's rename this one to bottom code. Huh. Okay. All right. I don't want to change on interactor. I want to change on my program. Program. Observable. Yeah. Just program. Well, do I even want that? Run view. Okay, that's back to that. All right. Something's wrong. Variable view. Oh. Well, and again, this is based on REPL.store. I'm trying to see if a way to generalize this. I don't know what this is considered. It's the publishing of it that's the interesting part, not the name. And I know there's ways to do the UI better than I'm doing. Where's the whole thing? Okay, let's run this. this on. Okay. Run. Okay, and that did push it to the bottom. Is that what we want? This one's a little more awkward. We started off with a very old school command line kind of thing. You would just type the lines one at a time. And then we added this capability to kind of display them, and you didn't have to type list or anything. Really, you should just be editing it in place, and we don't need the scrolls because of that. Variables empty. If we run, variables, okay. Something's weird here. Okay. Well, I don't think it's the scrolling that's the issue anyway. We can still scroll. Okay, so two things we noticed. Let's see. So we're doing this stuff. All right. And one thing I noticed is the input prompt isn't showing up. And the second thing is variable view is odd when showing array contents. As array called on non-array. Okay, that's kind of interesting. Okay. So I think we've solved this. Okay. By monitoring the actual variable we care about. Just crazy, I know. All right. And let's commit. Let's compare. Okay, we added separate tags for these. Change what we're monitoring. Again, change what we're, well, new tag and change what we're monitoring. And same thing here. Okay. No more diffs. All right, so fix scroll to bottom for each view. Okay. Now, all right, that's good. Yeah, take the progress we got. Input prompt isn't showing up. That is weird. Okay, so let's run a simpler example. Okay, let's do this. Print hello. Okay, that one is fine. I'm not going to overwrite that input high there, semicolon x, print x, replaces the line, run that. Now I'm inputting x, so if I input it, oh, how interesting. So I'm guessing our interpreter has the prompts to input. We just added the prompt like yesterday. Okay, we do print the prompt. And I thought it was working yesterday. I don't remember. I thought we saw this working fine. Okay, print the expression string prompt. And the line. Oh, no, that is correct. It does not do the right thing. Okay, so the problem is it's not printing the prompt until after it already tried to get the line. So it could not have worked. All right. And so our test is not, I think we just kind of tested at the outer level, tested the end. It looks right at the end, but it doesn't interact right. Input tests. My sorting is no better here, apparently. Okay, input. Input tests. Input with prompt. Yeah. Okay. I think we're gonna have to do something more like this. Test input prompt shows before attempting input. Okay, so input $, print $, interpreter run. Input hello. I guess at this, when the run comes back, we want to check that interactor.output should be let's give this a prompt. Okay, input, give some little symbol thing. $. The input should be this, and actually the question mark should come from that too. Okay. No new line. They input hello. Now the input should be this. That's them typing. That's the stuff we're printing. Okay. I believe this test will fail. Yep. Right where we thought it should. Okay. Interpreter. Okay, before the get line, we need to do a print. Do print string prompt. Oh, we got a question mark space. Let's fix that in the test. Okay. Interpreter prompt space. We don't need this expression. We're printing one string and we want to keep it on the same line. Then we print that, and we're going to print just their input and new line. That's annoying. I think our print could do that more easily. Let me add a note for that. Print could, how about into, now that I've deleted all these things or closed all these windows, print. Yeah, this flag could be part of the printables. Okay, let's save that way. All right, but the real test is this one. Okay. What? Oh, it's got to go higher. Okay. Well, actually, it's probably inside there. If the input is empty, there is no value. We need to prompt and then do this. Okay. Ugh. Okay, and I think given given we saw it fail at this level, let's run it and make sure. All right, good. Okay, yeah, that's more like it. Okay. Prompt shows on input before stopping to read user's input. Okay, let's run all tests. Okay. Let's see. I guess if there's no prompt, Let's see. Yeah, this should always occur. No, wait a minute. Expert string prompt. Oh, it maybe this program results with input may be messing up. Prompt should start empty. Okay, so we got hello with no prompt. Yeah, let's check this thing. Yeah, we've sort of pre-buffered the input. It really should be more like what we did in the other test. Input and then interpreter dot continue after input. Okay, because we don't support that doesn't happen in real life. It's only coming from actual input. Let's try these. Okay, and run all tests. Make input prompt show up before reading the values the user typed. Okay. Variable view is odd when showing array contents. Yeah. All right. Let's see what we see here. Whoops. Run. I guess we need this. What are your length and width and length? 8, 10, just for variety. Okay, and if we go look at the variables, V0 is an 8 by 10 array, or 9 by 11, and contents of C. All right. Oh dear. Variable view is in here. What is... I don't know why. C is very suspiciously the first entry. No, so it was empty parens because it didn't have any contents. All right. So we've got the key and value, which is the variable name and the contents. If you show array contents, well, let's see what array contents does. Key contents of key. We're at 130-ish. For each array, debug contents. I don't know, we're getting the wrong key, aren't we? Why? I guess it's some sort of display issue, like content key is getting bound at the wrong time. Let's. Problem is these. I can't really stop and print on the way. I don't know. The key is in this scope. Should be key. Value as array. Well, this is where as array is getting called on the non-arrays. From that, if it's an array 1, 0. I don't know why it's getting the old key value. We can create a smaller program to demonstrate the problem, I'm sure. Okay, let's say x equals 3, c sub 3, c sub 4 equals 4. Run that, and then see the variables. Oops. Oh, it didn't hit return. I've done that before. Run and look at the variables. See. Oh, how weird. Oh, that wasn't what I wanted to do. I should have done a equals 3 because now this is first and it's all happy and it's got the right thing there. Let's change this. Variables A3. Now this is A. Okay. Well, this could be better. I don't think it's necessarily. Well, it's not good. It's not. It's not completely terrible, but As array called on non-array. Do we know the name of the variable? As array. We don't. Okay. Hmm. Um. I guess I'm going to have to look at sheet a little more. Maybe I'm misunderstanding how this gets. Maybe we have to store this in a variable. I don't know if it's not state. Let's just try it as a variable. Private bar. Array name to show equals nothing. Equals key. Well, let's make this obviously wrong first. Cannot assign to property. Mark method mutating. Well, we can't do that. Can I make it state? I don't know. Oh, we still had one as array called on non-array. Yeah, because question marks is not even a variable. Okay, well, that didn't work. Let's take that back out. Okay, let's look at the sheet. Okay, they're just showing static information. Given item as a data source. Oh, what's different there? Is presented on dismiss and content. Item Optional source of truth for the sheet. Okay, this sounds closer. Sheet item, sheet detail. So maybe okay, maybe this is state. Equals nil. Is that more what they're doing? Okay. So I think when they click the button, they get that. Sheet detail. Item. Name to show. On dismiss. Whoa. String conform to identifiable. Inventory item is identifiable. Now in content is but value no. Let's revert this. Huh. Oh, that's window group. Maybe there's another thing we can use. Is presented on dismiss content. Okay, yeah, that's a static one again. This is the one we just had, but it's for views. I guess you can just attach those to just about anything. Well, it's pretty clear this one is more of a static thing. What can we do here? All right, let's get the other sheet. Item. Let's see. Okay, I'm gonna try this again. State private var array name to show of string question mark, and it's not gonna like that because it's not identifiable. How can I make it identifiable? What if, I don't know if I can do pairs here, string view ID. That's still not identifiable though. What if I had a type? Okay, I'm gonna make up a little type here just to do this. Variable dump or array view. Is identifiable. Come on, you're supposed to complain. You're happy with that. Okay, there we go. Yes. think I can do that. And then I can put the name of string and I guess value. Okay. Now this is an array view. Starts out nil. So it's array view question mark. We'll do that. Okay, so that conforms to that. If you tap, I don't know if I can capture the value. Array name to show equals array view. Name key value. This is item. Array name to show. Is that what they showed? Item, yeah, dollar array name to show. And the contents, yeah, we don't have to say content here. We can close this. Okay, and this close away. Okay, array contents. Array, I don't like view, but that's what we got for now. Okay. And then on dismiss, right? Contents on tab chat. Array name show equals nil. Okay, A equals 7. C sub 4 equals 4. Run that. Variables. A7, C is A. Okay. Messy. No, not so intuitive to me. Did I lose my run? There it is. Yeah, I don't think it's my only way out. Okay, let's run our basic one just to make sure. And I don't know, it's so hard to, I don't know of any good automated way to test this stuff. Maybe UI tests could do some of that, I don't know. Run. Okay, and the variables are, okay, and these, so it doesn't actually use row 0 like many people. And they sort of assumed it started at 1, or used it as if it did. Values are all 0, 1, 2, or 3, which corresponds to the, that definitely corresponds to the code. It generates values in that range for choosing directions. Okay, so V0 looks okay. W, I don't remember what W represents, but they may be flags. Notice, maybe we can figure it out from the code. WHV. I don't see who's assigning it to W. Equals C. C is 151. So I don't know. C maybe. So 10 by 15. Yeah, C may be counting up max 150. I'm not sure. This is a very opaque program if you haven't had a chance to look at it. Every line is like, this equals that, that equals that, that equals that. If this equals that, go somewhere. And it's really hard to figure out what's going on. This is printing. That much I can make out. Okay, but anyway, we don't have those messages about arrays not valid and stuff like that. So I think we've knocked this out. This probably, let's change this name. Oh, we don't need to show array contents anymore. Okay. Let's just call this array to show. And I'll call this array info. Info is kind of a poor name for things in general, but I mean, this is kind of a low level debugging view, so I'm not too put out. All right, and run. Okay, 10C equals 12, A equals 3, X equals 14, and D sub 12 equals $12, D dollar 12 equals array of strings. Good. I don't think it's a perfect view by any stretch, but it's enough to see some things. They are alphabetized. We grabbed a couple out of the middle and so on. Okay, so I think we're good. Make variable view show arrays property. Okay, 11. I think that's the best I can say. Okay, and save that. All right. Integrate newline into printable. And I think the other one I want to do is I think that is true. Okay, integrate new line into printable. So I think we can do this. Let's see, I guess we'll need to parse. So print has this Boolean on the end. I want to remove that. Well, actually, what I want to do is make anybody who wants to put the Boolean true, I want them to stick a new line in there. Where's printable? Tab, case new line. Okay. I don't think anybody's going to care about this. Oh no, interpreter does. Okay. Well, I think if I actually do it, new line return new line, I think nobody will care about that then. Okay. Now we need to parser. Well, here's parse. Anybody, what I want to do, so rather than deleting this Boolean and having the world blow up, I want to say you should, if you were going to set this to true, you should put your own new line in here. And once I do that, I'm going to not pay attention to the flag in the interpreter. Okay, so we need parser.swift. And I'm trying to make this a non-change. So let's find anybody who uses .print. Okay, so parser print true. Okay, so he should do a .new line. Oh, and this false. Okay. True for now. Okay, we'll leave it as it is. Okay. Now that will break something, so we can't quite stop here. Yeah. Okay, but let's go back to our search. Print true. Okay. Values dot last not equal thin space. Okay, if there are no values, we just do a print a new line, right? If there are values, let's add it in. If value, this should be true if this is true. So if it doesn't end with a comma or a semicolon or a comma, then we really do want to append dot new line. Okay. And we'll leave this condition for now. No, we're going to change this to false. No, I guess we'll leave it. We're going to take them out in a minute. All right. Yeah, so you will have a new line added if you don't end in a comma or semicolon. Those say keep on the same line. Okay. Print their expression tests. Okay, let's check this one. Expression true. We should have a dot new line now. Lexer tests. This is all print. Yeah, those lexer doesn't matter. Expected and new line, since it's a true. This should be dot new line. Oops, I guess no comma there. Print no new line. No new line. Print comma 1, 2, and should have a new line. Suppress new line, okay. That one has a new line. This one should have a new line. True, true. True, true, true. True. Oops. I think my trackpad just died. Okay. New line. Okay. I think every test with a print is going to blow up. Okay. Lots of tests. But now we do the interpreter. Print. Let's go to do print. Actually, let's go back. Should print new line. Let's say false. Okay, so now we're only going to print it if it's in the thing. And unless I missed a test, they should pass. Print number 20. Print number 10. New line. 20 new line. Okay. Good. All right. So back to green. Where's the interpreter? Okay. So now we don't need this. And really, since this is always false, we don't need the value there. Okay, so should print new line. We lose that. That puts an extra one on the back. We don't need it. Okay. So that should be good. Whoops. Do print false. Okay. Do print true, then we need a new line. And same thing here. Okay. Should pass. Okay, and then let's take parse. Now we got this bool in the end, we don't need it. All right, and so some places should complain in the compiler. Yeah, like all our tests. But we're removing that argument. Is there a go to next error? Oh, it's really annoying. Unfortunately, changing print is the thing we probably use the most in our tests because it's convenient, which means a lot of tests are relying on it, unfortunately. because it gives us visibility to any other statements effect, right? So understandable. Okay, let's build again. Build succeeded. So what are these errors? No. That looks okay. That looks okay. That looks problematic. Oh, what's the... Print new line. No, that all looks okay to me. Let me clear these errors as... Oops. We'll run tests. Hopefully the build actually builds. The test should all pass. Still messing up this one. Print. Oh, that looks completely wrong. I should have two. Okay. Okay, I'll commit that. So, make new line or add new line to printable. Remove Boolean flag from print. Make colors of print pass in explicit new line if they want it. And I remember a little debate in my head, should I have just done that in the first place? And the answer was yes. Okay. To do, integrate new line into printable. Yes. There. Okay. I think I want to start this. Well, no, I got 4 minutes. Let's take a look. It'll probably be easy to revert if it just had to revert everything tomorrow. So I'm not going to mess with it then. I'm just going to look at it briefly. Okay. So what I expect to do, token, I expect to pull any field, anything that's in these values, I'm going to pull up to token. So it looks like I need a string, a type, and a float. Possibly I could get by without the int. Yeah. String, float, and int. Okay, so those fields up in here. And then I need to find anywhere he uses one of them. Well, I need to set them in here in each case that matters. So error, string, and so on. There's probably people returning token types that need to return tokens now. So it may not be a one session thing. I don't know. Let's find one. Error may be the worst. Yeah, here we're returning token types. And then who calls next token type? This. Yeah. I don't know if anybody's calling this by themselves. Anybody else? No. Okay. So we can inline next token type. Compute the value. Error. All these things returning token types. Yeah, there's a little. Okay. Yeah, we'll pick up there tomorrow. So, my goal by the end of tomorrow, I think we've knocked off everything I expected to knock off today. It would be nice to do this maybe, but I think we'll let that one go. If we can get it so that everybody's using token instead of token type, there may be routines that still return token type, but mostly things are going to have to return the whole thing because these things like this, handle variable, right? It returns token type, but it passes the name back. So at that point, I would just assume it built the token and was done with it. Okay, and we'll make it do that. We can do it from the bottom and then build it up and reassemble it if we have to. Okay. Thanks for joining today, and it's been a good week. We've just about finished this phase of this project anyway, and we'll see you tomorrow, 10 a.m. Eastern Time to 12:30 p.m. or 3 to 5:30 p.m. UTC. Have a good evening, and I will see you again sometime in the future, I hope. Bye-bye.